advise that you stay, even if you never use Python. It's good that you get an idea, and you can see then the differences between R and Python. Let me just set this to run. Okay, so yes, we are the second day of the training session, so Open Data Science Europe workshop. And today I will talk, this block, I will talk a bit more about visualization, so data visualization. And also I will show you a bit, we will look at the data and I will show you some ways you can visualize data, because when you do machine learning, it's very important to be able to also visualize data and visualize the models and then track if there are any problems, to see if there are any problems. So let me share my screen. I did send you also some code, just example. Maybe we start with that. If you remember, yesterday we had these 3 case studies. The very nice case studies. Every case study comes with a publication, so they're very well documented. And this is quality data sets, and you can really test your machine learning skills with this data. But it is a highly complex data. It all goes to 4 dimensions, right? The Cook farm is 3D plus time. So it's a really complex data, but it's a data, as I said, it's a high quality, it's been published. And one of the data we use for this project is this European forest tree species data. And Carmelo yesterday explained you all the work we did. It took a long time. I think 1 year ago we started with the points and models, and now we finally have the map. So it's been a long process. And then what we looked here, it's a 1 case study with modeling the Fagus sylvatica, the beach, the spread over Europe, and we saw that yes, we have these points cleaned up, and as you can see, it's there's maybe some gaps in the Balkans, and but otherwise it's a clean data sets. And when we do an overlay, space-time overlay, so we also take the year, we fitted the model, and we can make predictions of this species changing through time. And also you can see that when we look at the variable importance, so the model is quite okay. Well, we have this I, so I don't know what is the R square, but I remember Carmelo showing that you see the errors in probability space. They're like plus minus 10%, even less than 10%. So the models is quite significant. So we can predict really nicely distribution of these species. And then we plot this variable importance. And so what's also very nice, that all this Lanza data we prepared, it correlates. So the red band from the Lanza, the lower 25% quantile, it's the most important. Then we have the proba V FPAR, also, which is kind of measure of biomass. And then we have the green band coming up. So it's mainly basically Earth observation data that helps us map these species. And then maybe later on there was some bee vegetation, etc. But as I said, the good news is the Earth observation data can be basically used directly to map that species. And then we do predictions, and we do only 3 years. I could now add an extra year and predict, go back. But we may have these predictions, and we make a little plot like this. And so now we can do some diagnostics. And so the first thing we would like to do is to open that in a GIS. So we could go and open this in a QGIS, of course. So let me start the QGIS. And if we open the QGIS, we have to customize it a bit. We can add a legend. We can add a satellite image in the back. So let's do that, and then we can look at it differences between years. So turn 1 year on and off, and look at the differences and see if there's anything correlated with maybe with some location in landscape, etc. So that's what we can do until my QGIS starts. Let me see. I don't have that prepared, so I will just. Oh yeah, I have it. Sorry. So here's this QGIS. This actually with all the points used for training, the 700,000 points. So it's a bit larger. And then now I have to drop this. So I have to turn this off. Okay. And here's the Google. And here as you see, the points. But we have made predictions. And because we made predictions, I can drop now these points, the prediction points. So that's only here. Oops, sorry. It's under my Git. So in the output, you can see the prediction files. Good morning. So here the predictions files, and I have the predictions and the errors. So let's put I put a one image on top, and then I zoom into that image. And now I just see black and white. So maybe I can customize display. I can pick up some nice, I don't know, legend. Maybe I can create also some new legend. So here, well, I can put this the same as the one that I use, let's say similar. Viridis or magma, so like this. And so now we see going from 0 to 100%, the density of the Phagos sylvatica. And you can see this is one date, and this 2015. So let me add the 2019, and I can copy the color now. And so now I have two dates, and now we can look how much does it change. We can look at the changes through time, and you can install this value tool. Also very nice, so it shows you for every pixel. If I zoom in, I can see the difference. Looks like 39% in 2015, 88% 2018. So it looks there's an increase for this pixel. Should be also visible here, right? You can see there's an increase. So this way you can see that. There's also a transparency tool. Let me put that plugin. So transparency. This one. So we can add the transparency, and when I select some layer, let's say this one, I can play now with the transparency. As you see, it will change. So now if I zoom in, I can see actually in the background, I can see these are the 100 by 100 meter pixels. So I can see in the background what is in the background. And it looks like these predictions, they match kind of the distribution of forest, you know. So although here there's a bit more forest, but looks like they don't cover the whole area. And so these are the way you can predict basically visualize the predictions. This was the QGIS. You see, I had to drop things. There is also a package called RQGIS. So you can from the code from R, you could also send files, and then it's a bit easier to open. But otherwise, you know, it's lots of point and click. So there's alternative way to visualize is to use the PlotML. So here I made a little code. This is a code to loop year by year. So what do? I take that prediction object, and I say I want to use this variable as a color, and I want to write in a file, and I define the file name, and I loop by year, and also I make for every year make a different raster. and I can make it that it clips from 0 to 100. So it's automatically, they're all scaled. And also I can put the date, and you see I can put begin date and time end date. So I put the beginning of the year and end of the year, okay? And if I loop this, I will create these KML files. Each of the rasters will be reprojected to latitude, longitude, and there will be a PNG created. And then I can open it in, let's say here, I can open it in Google Earth, and then I get this thing. And now we have it also, we can look at it three-dimensionally, and we can rotate. You could even simulate like situation of the sun. Oops, sorry, this one. So you could simulate, looks like still dark in, I think, where is that, in Italy? Suspicious. Okay, because I took this. I have different date, but so I can play with that, and also I can if I move around. Let me go back to this. So you see, if I move around, now I have 3 maps. I can see how things change. So I can simulate that change through time. Yes, and now we can see where the changes are the biggest. And also in when you do in 3D. What's very nice, you can see that's a part of the landscape. So so we can see that some like beginning of the hill here. Maybe I will put a bit of here. I will put transparency a bit. So like this, and so you can see that's the beginning of the hill. There's the ridge here. So on this side of the hill, there's not. On the other side, there's not many changes. But on this side, looks there's a changes, right? You can see really drastic changes. And then we can even zoom in and try to see the trees. Eventually, you can drop also, if there's a road, you can drop and open it in street view, right? And all these things we showed yesterday. So you really, this really enables you to almost like jump on the field. And it is a much more, for me, it's a much more powerful than doing it in QGIS, of course, because there are some here, there's some photos. So let's take a look. There's a photo, and I see that's mainly coniferous forest. So I see what is the landscape. So that way you can, you know, you get space-time data in Google Earth, and you can visualize. And also now when you can put these PNGs, you can put them on a server, and then what you do, you just send a KML file to colleagues, and as they open it, then they see without having to do any GS knowledge, they can just click and they can see what's happening, and they can interact. So that's a very powerful. Of course, I could have made in this code. I could have made predictions for 20 years. That would be even more interesting. Yes, and then also write up some description text. So when the people click on it, what is it? Also add the training points on top. And then you can create a little project. You create a whole project with KML. It's so powerful. You can put so many things. And you create a little project, and you even zip it in the KMZ. And then you send it to someone, and it's kind of out-of-box project. It tells a story. You can even add a video. You can add slides. You know, so you can sky's the limit really with KML. And I think it's a good way to engage people with basically geography, and to understand, to also understand how things are connected in landscape. Here's a nice example. Carmelo, look at this. This is a bit steep area, but here there's a difference between years, right? So I don't know if it is really because obviously the trees cannot disappear and come back, you know, in 2 years. So there is also some noise in predictions, and it's because of the Landsat images. So we are possibly going up and down with predictions, but there's not really changes. They're not exact changes, but it's really the noise that you see. So then you have to look at the uncertainty for some pixels and see whether it's something that we should worry about. But let's say if there's an area where you have for multiple years, suddenly trees disappear. It could be, most likely it's a clear cut, or it's a forest fire, or it's a change of land use. And then when it's a, you know, when it's a really distinct jump, drop in values, then most likely this is not noise. You know, this is really something happened. There's a change of forest cover. And as I said, you can interactively now with our data portal, you can go and interact, and you can, for example, you can open all the Landsat images. These are the ones that we prepared. So this one, and you can then maybe go to the same area and see whether these satellite images, maybe they also have some issues. So it will be nice to find the same area and then scroll through the Landsat images and see if there's also some issues in the Landsat images. Because it could be that some Landsat images could be that they have issues with the quality or how we do the gap filling. So, but that will be something interesting to see. Yes, I don't have time now, but I'm just giving this example, and so that's very interesting to look at the changes. And as you see, when you do space-time predictions, eventually, if you do everything properly, then once you plug it in the app, then people can go and animate, and they can see changes. They're not really, as I said, Europe is not so drastic changes. So we discovered there are some changes in. There was this place in Italy. By accident, we find out L'Aquila. Where was that? Somewhere here. Do you remember? Yeah, here. Carmelo, you remember? Was it this one or this one? This one. Yeah. So you can see. I think here there was this earthquake or some fires. Oh, you see how it disappears. Do you see? And so this is a known. I mean. You know, the really forest disappears. So this is not noise. You can see if I navigate, you can see that there's really this patch of forest that suddenly disappears. And if you want to check again, you can open some high resolution satellite image, and then we can see. But the satellite image only shows the recent image, right? And so we see that there is less vegetation now. And so something happened here. Did you ever discover what happened? Was it a fire, or it overlaps with the earthquake time? No, 2007. My guess it's probably it was like a big fire or something. But so that's what we discovered. And yes. Okay, let's check Ireland. Which any specific place? Give me some. All of Ireland. Let's see. Let's go somewhere here. Kilkenny. Is it with K? Kilkenny. Oh, I don't know how to spell it. With one L. Kilkenny. No. Wetlands, where? Where? This thing? Okay, we zoom in. Let's take a look. Oh, looks pretty stable. This forest patch, but yeah, here you're right. Here. Oh yeah. Yeah, I see. Yeah, it comes back. You know, we made so much data, we don't have time to check it visually. So that's why we make a viewer, and we want to enable people. That's why one of the reasons we do this workshop. And on Thursday you will see they put the whirlwind. It's integrated now, so it's also 3-dimensional, and it's like in Google Earth. You can look. but it doesn't use Google software. So we use the Whirlwind, and also we put the cesium, this one. And so you can visualize it also in 3D. So we can see here, this is also some landscape. And yeah, it's nice to see that it's really drastic changes. This cesium, I think it should work also if I click. Yeah, it works. So if I click, I also see in which year we can trace back. Oh, year 2000, either 12 or 13. You see, this is noise. This thing, it's a noise between years. But then if you smooth the noise over like 3-4 years, then the difference you see, no, it's not noise anymore. This is so that's the time series analysis, basically. So thanks for pointing to that. And yes, please use the viewer. And also, if you're not sure what you're looking for, you just have to use this search, and we will keep on adding layers. And so you can then visualize also Corine and many data sets. We will keep on adding layers, and so you'll be able to follow that. So that was about the Google Earth. So it's very powerful, right, to do this, to switch from R to Google Earth. And how is that possible? Well, I made it little functions. I made it, so let me talk about that a bit. So I made functions to plot directly from R, and there's a package called PlotML. And also now I work with the GDAL to tiles. Ever use GDAL to tiles? It's also for, like, the PlotML is for small data sets, for sample data sets. So if you have just this tutorial data, right? But imagine if I had a data image which is like, I don't know, 20,000 by 20,000 pixels. Would you load it into R? No. If you load it into R, you crash your R. You need a RAM to infinity. So you wouldn't load it to R, and so, but you still would like to see it, and you want to see it the same way Google Earth displays things, which is with pyramids and with tiles. And then you can use this GDAL to tiles. It takes a bit of time to process, but let's say 10 minutes, and off you go. You have then a KML, which is the ground overlay, and it can be a large geotiff, and you can visualize it. So it's also quite amazing. So these are the two things we recommend. For the small data, you can use PlotML, and for the larger data, for ground overlays, you can use GDAL to tiles. It only works with raster overlays, and there's some tricks how to do it. You can read more about the PlotML in this paper, published in the Journal of Statistical Software. I can show you that paper. It also comes in a package. It's a vignette for the package. When you publish in Journal of Statistical Software, then your paper becomes also vignette. So it comes in the package, and every time I make a new version of the package, I have to rebuild the vignette. It's an ultimate test that my code still runs. And so every time I update the package, the paper is also updated. So, and that's a nice for people. You can go and download from the journal copy, but you can also take the PDF from the package. And then if there's a change in the code, then people will see where's the change. It will be just few things in change, but it will compile. And so if you see this PlotML, we started looking something like object-based. We wanted a package object-based. So we said, okay, you have a 2D spatial points. If it's a point structure, if it's a gridded structure, then it's a spatial grid, spatial pixels. And if it's an irregular area, then it's spatial polygons. Then you have the 3D. You can have voxels, monoliths. Then you can have irregular voxels. Then if you have space-time, the same thing. And then 3D plus time. So we looked at all these cases, and we said, let's try to visualize them all. Well, we don't have the voxels, never worked out. There is a way you can do kind of voxels, but you know, it's still tricky to, like a Minecraft, you know, to visualize a Minecraft type objects. And I don't know, I'm not sure how would I do that, but it is theoretical, it's possible in Google Earth to also add voxels. So you have not only pixels, but voxels. Because this collada type objects you can build and then you can display them. So this is all these buildings. This is just a simple example with we also played a lot with this aesthetics, what we call aesthetics. So like when you make a plot, so you can, and I think in the TMap package, it's also very well explained. So you use these visual variables to display a value. And so in this case, how many visual variables do you see? Like what is, so I want to emphasize the values. So there are point samples and there are values. So this is, I think, sand content. And so how many visual variables do you see here? No, visual variables is like you use, for example, color to emphasize differences. You use the size of the bubble. You know, these are the visual, let's say, called variables. And we also use the text. So here you have 3. So you can see by text, by size of the bubble, and by color. You can see the differences. And why would you use 3? Why would you use 3? For visualization, maybe it's inefficient. It's kind of when you use 3, you emphasize it. It's kind of like you underline a text and you highlight the text, right? Then you're sure that people don't miss it. Yeah. So then you emphasize it. Maybe you make it more dramatic. I don't know. But it's nice to put a text also, because the text is like people see, okay, these are the higher values here. Higher values are here somewhere. But what are the values? So they can people can actually see the actual values. And this is just comparison to see the same type of aesthetics in used to be like lattice, and today people use ggplot. So same type of aesthetics except without numbers. You see in R and you see in Google Earth. And obviously, if you get, as soon as you get something in Google Earth, it is much nicer to interact and to basically open and look at things. And so you can emphasize this aesthetics, and this is a step further. So you see, this is aesthetics. The shape is aesthetic, the color is aesthetic, labels, altitude, etc. And you can go further. You can also add elevation proportional to the value. So where you have a high values, you will have a high. It's like how is it called this? Acupuncture, you know, and this is the acupuncture to Earth. So you can put this, it's very simple. I mean, you just put this altitude basically. So altitude is a variable multiplied value multiplied by 10. So emphasize it even more. And you get this thing. And this way you can do this different aesthetics. And sometimes it helps people to realize what is the trend, where the high values are the low values. And sometimes you can see also high values next to the low values, and you can see there's kind of like a bridge here, bridge of values, right? And so that's a one way to utilize. And then we also made these lower level functions, so you can create your own functions to visualize. And once you figure it out what you want, then you create your own functions. So you can do KML open. So you open to write KML, then you can put multiple layers. And then you do KML close. You can also add a logo, a screen overlay. So you can do lots of things. And that's what they do here. That's an example exactly in this. You see, this is a lower level programming. I don't use the KML open, KML close. I just use the KML. But then I put a lot of things I define. And I put a lot of parameters. And actually, I put probably too many parameters you can change. And then people get lost and they don't know how to do it. But if you look at the documentation and if you look at the examples, you can see that, yeah, you can change a lot of parameters, and by changing them, you get something like this. How much time will it take you to make something like this by hand? Probably to put also the legend in the plot, it will take you quite some time. And so this saves you a lot of time. Even the PNGs, I had to figure out the PNGs. They are usually in Google Earth, they don't display so well. So I had to figure out the way to go around it. So I made also like to build in transparency and to how do you say, densify the PNG so you can see actual pixels. And then eventually the effect is very good because if you have a space-time object, you can now see changes in that distribution of that species. And also you can switch to this time scale time lapse in Google, and this is something very nice because you can really do interpretation. We can go back in time and we can see this area. Now, if I go to 1997, what happens? There's no high resolution satellites, only from the 2006 for this area. Only from 2006, I'm getting high resolution, and then I can scroll a bit further. And you can see if there's any changes. And there are some changes, you know, we can see here, this patch, for example, here, it used to be a bit more open. And then a couple of years after, now it's filled in. Do you see the difference? So, so something is changing, everything is dynamic. The only Greek philosopher that was really right in many of his theories, the other Greek philosophers, you know, eventually they discovered, no, it was a too naive theory. But do you know which one is that got many of his theories are still actual? One of them is Heraclitus, and his basis of his theory, the only thing which is sure, the only thing which is stable is the change. It's yeah. So so you see this this is the way you can then do visual interpretation, and there's a lot of these photographs. But to be honest with you, there are many more photographs, you know, but photographs are scattered all around different systems. It's a real pity. Like, for example, there's the iNaturalist photographs, and it's a pity that we don't have them in Google. Maybe there's a way to put them in Google Earth, I don't know, because it depends on the license. Google doesn't take some licenses. But it's a pity that we cannot add, maybe there's a way to add photos, but eventually it's also very nice to look at a photo and you can see how that area looks like, even though there's no maybe Google Street View and etc. So so that's why I think this package PlotML is still, I don't maintain it so much. I haven't touched it actually a couple of years. So I don't maintain it, but it works, and it works now with SF, thanks to Andrea Ghilardi. It works also with SF classes, so you can plot SF classes. But you cannot plot large rasters. It's not going to work, so be careful. Also, sometimes with rasters, maybe I show you that also. With the rasters, it's a good idea to plot it. If you really want to see the effect of pixels, good way to plot it is to put, for example, to convert pixels to, I think it's this one. This one. So here, I can convert. We can convert pixels to polygons. Why would you do that? So it's a much bigger file. I mean, but why did I convert pixels to polygons? Because if you do this, you can actually really see how much when you do this aggregation, you can see everything that falls into pixel, right? Now, because now the pixels are defined precisely. If I put a PNG, then unfortunately Google Earth compresses PNG. I don't know how it renders it, but you lose that. You lose the edges. You don't see the edges. And when you put, sorry. So when you convert pixels to grid, it's a single line. It's called grid to poly. I made it, and so it's, you know, you do it in one line. But every pixel becomes a polygon. So the size of the polygon, I don't know, 10 times bigger than the raster, because raster is a super simple structure. You don't have to. A polygon has to know every corner, right? It has coordinates of every corner, so it's very precise. But sometimes it's good to see that because if you have all the scale issue, aggregation issues, you want to really see what falls in one pixel, So I can see here is a bit of road, bit of this, bit of that. So you can see that pixel complexity, because once I zoom out, then I'm not aware. It looks to me that pixels are homogeneous, but they're not. So there's a quite diversity still. So today, with the Sentinel-2, the cutting edge resolution for the world is 10 meter, and there's the first products at 10 meter. As you hear, maybe there was the land cover product, the 10 meter global. So the first products popping up at 10 meter. But even beyond, if you go beyond 10 meter, you can see objects which are less than 10 meter, and eventually you can see individual trees. And yeah, it all makes difference, of course, depending what is the purpose of the data and analysis. So that's also another thing about PlotML that when I made the package, maybe I didn't maybe spend so much time optimizing it, but I did spend a lot of time thinking of diversity of objects. And when you look in the tutorial, so the tutorial comes with it's a visual tutorial. So let's say if I go to that tutorial here. So here's a visual tutorial. So how does it work? You have a visual example, so like this one, and then you see the code. So you can reproduce. You can put your data. So here's an example of a code, and so you can put your own data, and you should get a similar type of view. So that was kind of the idea, to have like a visual tutorial, and then I put a lot of examples. There's when you do like terrain modeling, you do some hydrology, you can put contours, and you can put them together. You can overlay, you can put this grid to poly. That's the one I was showing. And you can do also some space-time. So here's some space-time examples, this one and this one. So let's take a look at the space-time. I already opened it in the Google Earth, so we can look. So here's an example. That's the Croatian data set, by the way. We also use it in modeling. And so what you see here, this is this time series of MODIS, and we can scroll through time. We can scroll through time and see the values changing. I think I put only, this is maybe just a few months, but I also put this thing, which is the stations. And remember, this is a way to visualize changes, because here's a station, and I can make an R plot. I make an R plot in R code. If I had like 1,000 stations, I make 1,000 plots, and then I put these PNGs with the PlotML. I define them here. So let's see properties. So I define them as a description, and I can put it as like this. I can generate it. And when I do that, when you click on that point or this point, you can see the differences in different meteorological stations for that year. You can see there's some missing values, but this is the actual observed data. And then you compare that, of course, with the satellite images. And this is the 1 kilometer MODIS, right? So you can see how the things change. Also, it gives you an idea that sometimes some of the layers, they don't overlap, so there's different missing values. So this is all, this is all the reality of this MODIS data, right? And so that's the space-time data set. Now I had this thing turned on, so I was going, I couldn't see. So there's something you have to learn how to play with in Google. But it's very fast, it renders very fast. When you do a smaller PNG, so any PNG up to, I don't know, 10 megabyte a PNG, it's going to work very fast. It doesn't eat a lot of RAM, so you can really visualize things and see the differences. So that was, and then you combine it with plotting, R plotting, and so you have kind of scientific visualization that as people interact with the map, they will click on stations and they get these curves. And that way you visualize space-time data. Then this data, this Cook Farm data. Also remember, it's in the tutorial. This is a small data set, nothing PNGs, but it's a 3D plus time. So I created here. I think this is 1 month, 1 month of soil moisture, right? It doesn't look nothing special, but actually I think it's 2,000 PNGs. Yes, because you have every day, and then you have 1, 2, 3, 4, 5 depths. So you have a five by every day, and easily you multiply and goes up. And so now we can look how this. So that's the really so the 3D plus time. I can zoom in maybe somewhere here, and I can now animate what happens with soil moisture. And I can see sometimes it's in the deeper soil, you have the higher soil moisture. There will be some place where the water accumulates. And we discovered that usually it's because of the soil texture. The soil texture, if it's more clay soil or BT horizon, then it keeps the moisture. But so this is a full-fledged 4D GIS. Have you ever seen 4D GIS? Maybe somewhere in computer games. But this is the free, really scientific 4D GIS, and this is only possible at the moment in Google Earth, as far as I know. You can do it maybe in GraphGIS. Veronica will talk today about GraphGIS and also Spacetime GraphGIS. I don't know about the 4D, so 3D plus time, but this is a full spacetime. And so these are the depths. This is like 30, 60, 90, 120, 150 centimeters. And what I do a trick. I put the layers on top of each other, like they're in the sky, right? I do a little trick, and this way I simulate like, so you visualize it in a landscape, but you simulate that it's actually the layers above the ground. Because there's no way in Google Earth to go. Have you tried going below the ground? There's no way. But have you tried going in the ocean? Have you tried going in the ocean? In ocean, you can dig, you can zoom in into ocean, and you will, I think, sink. Eventually go under the ocean. Have you tried that? And they have some points where they put underground models and things. So that's this. I think even maybe you can no, but there is in the ocean you can go inside, and here in the ocean there is a point, I don't know, and then we can I think they put the bathygraphy or something. So now we are on the bottom of the ocean, and we can see. Have you ever looked at that? You can see the mountains in the underground. So now I'm going below. So people even don't know the lots of functionality, but remember, probably these people that made Google Earth and people that use it, they maybe never imagined that somebody is going to figure out to visualize underground structures and processes by plotting it above ground. So, but KML is very flexible, and when I started using it, I said, wow, this really sky is the limit. You know, if you're creative and if you know the code, you can really create this scientific visualization, especially for geography. And then you just send them a KML file and people open. And if you put most of the data on the web, so then the KML file just calls the data from the web. So the KML file can be 1 kilobyte. You know, you send them a 1 kilobyte, and you can even tell a story. You can put, as I said, slides and videos, and you can even animate it. You can record how the story should go. So it says, first show this, then show that. So it's really out-of-box solution. And I was thinking that in future we'll develop whole projects. We just give people a KML file. But it's not so simple because we started like with the Open Land Map. I also had this ambition to put Open Land Map to put everything in Google Earth, and there is a button here. You see Google Earth. But it was not simple. It took us a long time to convert things, and I don't know if it's a good result. I can show you that now. So all the layers that are in GeoServer, they can be also added in a Google Earth, and then you can pick up the layer you want. So there's all the spatial layers. So let's say this is the topographic wetness index, but I have to turn it on. So now it will plot it And I have to turn off the time somehow. I have the time somewhere. It is still loading. So it was not easy. So we still don't have the best effect. Let me see. This one doesn't come. So it's still querying the GeoServer. Let me try something else. Northness, eastness. Let's see if this works. So yeah, it doesn't work. We have to update it. It's not simple, but it's supposed to call the PNGs directly from WMS and then show it. This is the formula, but it could be that this URL. Yeah, I think the URL changed. GeoServer. Yeah, we changed the URL. So I can wait till forever. It's not going to work. So I have to update this. But that was the idea, to put everything in Google Earth. And I was thinking that's going to be the way to do projects. But unfortunately, it's not so simple. And this PlotML, it has the potential, but I'll have to reprogram it, I think, from scratch. At that time, I didn't even know how I program in R. I did the best I can. Now I have kind of, I understand the logic. So I will have to reprogram it and make it. I was hoping that somebody else will take off also, but it doesn't unfortunately happen so easily. So that was the PlotML. Let me go back to the slides. And I don't know if you never used it, but remember, just the easiest way to use it is to visually go to the gallery. So you come to this gallery and you say, I would like a visualization, something like this. And then you will see the sample code. This is the distribution of the Yeti in US. This is actual data, by the way. There's a paper published. They published a paper in US. Lots of people see Yetis, aliens, you know, that's US. Then there's an organization and they collect this data, and then somebody made the species distribution model for Yeti, and they published a paper. They said this is the species distribution, and I reconstruct it. I take this data from the paper and I prepared this little logo for Yeti. I found it somewhere, and so sorry. They make any predictions based on the data? Yeah, this in the back. What you see is yeah, here, there's the code and there's the paper. Where's the paper? Maybe I didn't put it. Maybe it's somewhere here. No, I have to go to the data set name, and so then you can reproduce that. And I will download it now. Let's take a look. Bigfoot. So here's the Bigfoot, and you can see these are the predictions. There's something with these pixels, they overlap. Let me see. And this is the model. I can put also model exactly for the Yeti. This is the result of the model, the importance. So what's the most important? Yeah, and you can see here variable importance, and that's the probability. So, I mean, you see it matches. They discovered, I mean, it's highly correlated with some brown bear, I think, or something. So it was highly correlated. So they kind of wanted to prove that actually what people see, it's the brown bear, probably. But there's a lot of observations. I think, let me check. I have the paper Bigfoot. Bigfoot, yes. Here's the help text, and there is There's also some article in the journal. Yeah, Bigfoot Research Organization, BFRO. Ever heard of it? Bigfoot Research Organization. And you see here's the code how you can reconstruct that. It's a couple of steps. It's not you have to fit a model and then you plot the predictions. You make the predictions and plot the predictions. And here's the paper says predicting the distribution of Sasquatch in Western North America. Anything goes with ecological niche modeling. That's the name of the paper. I can send you that. I'll send you that through MetaMost. So sometimes nice way to popularize science is to publish papers like this. So yeah, so that's also with the PlotML. You can do many things, and you can kind of pack the results of analysis with this screen overlays, ground overlays, points, polygons. You can play with the statics, and then once you visualize the data, then when you share the data, as I said, we will focus on this Fagus Helvetica. So when you share the data, then people can actually see. They can set up transparency, right? And they can see where exactly and why there are changes. And that makes it quite powerful, right? Because when you zoom in and display in 3D, you can see where in the landscape Fagus Helvetica comes. Look, the Fagus Helvetica usually comes on a sloping areas. Is that correct? The slope comes up as a good covariate. But okay. Well, also, you know, most of forests are still on the slopes, on the areas which are difficult to access. Did I touch anything? Ah, thank you. So yeah, that's the PlotML. There's other ways you can visualize data. One of them is to use this Google Earth Engine map, but this one is in Python. It's a Python package, and then you have to basically you do it by uploading data to Google Earth Engine, and then visualizing. Yes, Pablo. Ah, yes, sure. Let me put it. So here's slides. So you can use this package called Google Earth Map. Oh yeah, by the way, the Google also, they don't do many changes in Google Earth. For me, it was amazing software. 10 years ago, I was going like, finally, this is the proper GIS, right? Because especially when you could do KML and you mesh up all the photographs, and I said, "Wow, this is it," and it's fast, scalable. And now I notice they don't make much additions, very little change last 5 years. And for a corporation like Google, that means that they're not interested. So then they started with earth.google.com, and this is a web version, and it has extra things. However, if I upload my KML file, it doesn't support. So I don't know what do they want to do with this now. This is like you exclusively, you can just watch only what they have, because if I go and I say I want to upload somewhere, it's even difficult to remember where is I can do projects, I think. Let me see. Create project in Google Drive. Let me see if I do that. So I can call it somehow test. And then I say new feature. So now I think I can upload. Let me see, I can share with people. But how do I upload add place mark? This one will just, so I can just add this. But if I want to upload the KML file, I'm not sure how I do that. Have you maybe tried using this? It looks quite quite difficult, and almost it seems to me that there's really no way that I can put a KML. I can definitely not drag and drop it. And here I have some Voyager. I'm feeling lucky. These are the projects, style, distance, but I'm not sure how do I upload and put a KML file. Have you tried playing with this? There is it makes it on my Google Drive, so I wish I could just put a full screen slide, draw line placement. It looks it has very little functionality. I can export, I could manually do stuff, but I don't know if I can do anything serious, like to upload a lot of data. And I would like this a lot, of course, because it will be nice to be able to, put the data here and then send a URL. You just send a URL then to people, and then they see. Okay, and I'm looking and which one? You have it, I don't have it. Yeah, I don't know. I can reload, let me see. And yeah, I just don't, and you get some button to add?
Yes, open. When I click on make a new project, so I have to open.
Okay, let me try to make a new project. Okay, see, open project, create project, open project. Import KML from computer. Okay, let's do this. And so now I go to these ones that I prepared. But I want literally I want this last ones I prepared. So let's take a look. Even if I put just something like this, these are just points. If I put this one seems to work, yes. So I can share the points. So this is exactly the same as I created them in Google Earth. Yes, but if I want to add a ground overlay, so if I go as here and I said I want this forest predictions I made. Which one is the forest? No, sorry, I'm in the wrong folder. So here the forest predictions I made. Probability doesn't, and if I cannot upload both, it doesn't work. But of course, if I just put this one, I get no ground overlay, right? So how do I get the ground overlay? That's the question. I could put here a picture, maybe. Okay, so now I can, I could maybe link it, select from your device. Okay, let's take a look. That was the 2000. It doesn't matter, but I put this one. And now still doesn't want to show. So yeah, it's not, doesn't look simple. It's definitely not simple. Now it shows here in the preview. No, I think it attached probably attached as a description. This is just adds the description, I think. Now let's remove that title, but I cannot put the bottom, the ground overlay. I cannot put it. So, but let's say if it does, if I manage, maybe I am doing it wrong way, but I tried it a few times and I gave up. I said I didn't have time. And then I read something that don't support that the ground overlays on some third party. There has to be all in Google Drive or something. I don't know. So, but let's say if it's possible, then you can, once you finish the project, let's go to projects. So I created this one, then you can share that project somehow, right? You can go and say, export as KML, but there should be a way you can also share just the URL. But again, I didn't leave it. So I didn't play too much with that. So I don't know how to do it. But if you figure it out, that will be a way. Otherwise, you can always use, of course, the Google Earth. That works, no problem. Maybe it's better to use it because it has a cache. You can increase, in Google Earth, you can increase cache under options. So you can say, I want a larger cache here. Now it's a 1 gigabyte. I can put, 6 gigabyte. So you increase the cache and then it's a bit faster. You can see I can move really fast. And because it created the cache, it goes very fast. It goes as fast as a QGIS. But if you figure out how to do this, please let me know at the moment. I'm struggling also how to share that, how to share the data. So just by sending a URL so people can see exactly, that would be very nice, but not easy. No. Maybe you think maybe there you could upload KML easier. It looks to me that I think maybe it's combining the Google Drive, you put on Google Drive or something, and then, but how does it know the address of that file? So this thing I don't know. So maybe that's something about that to do. But as I said, I haven't figured out the easy way to do it. Yeah. Okay, and with this thing, I can stop. I think I showed you more or less everything. Let me just make the conclusions. So you have, oh yeah, there's also map view. Map view is in R, nice package, and maintained actively. But it's usually it's a 2D, and you create a HTML basically, and builds on top of leaflet, I think. So you can create visualization like this, and they're interactive, so you can click on the points and you can change transparency, background layers. It's also GIS out of box. You send a HTML file to someone, and they open HTML file and get in a browser WebGIS. It's also kind of out of box. And that also has aesthetics, and you can do lots of customization. You can also do comparison. And then if you want to visualize something in Google Earth, but it's a large raster, remember the PlotML, don't load large raster in PlotML. You're going to just crash your machine. So there's a road to nowhere. So what do? You use the GDAL tiles when you install GDAL, and if you have Python, then you just run this Python script. And you specify which projection you want as output, and you specify output directory, and then that's it. It creates a KML, and then you open it, and you have the pyramids, and you have the scales, and you can pick up how many scales you want. I put here 1 to 6. The more scales you want, the more it computes, exponentially more. So if you say I want only 5 scales. Okay, if you want 6 scales, then it computes, I don't know, 4 times longer. If you want 7 scale, then it computes 16 times longer. So it's exponentially more. But before you can create, you have to first take layer, you customize it. Maybe I could do that. So I take the layer in QGIS, then I have to customize it. So I have to be happy with it. Then I have to, let me turn this off. So here I customize it. Okay, I put transparency. I can turn off transparency. Other way around. So here I customize the layer. And then what I do is I save that layer. I say export. And that's, if you don't do that, then you won't get the PNGs. Then you say rendered image. And basically we export to GeoTIFF, but we export it as RGB. So it will, let me make a test, TIFF. So what it will create is, I can put it in the same folder. So what it creates, it's a TIFF, which is basically RGB. Maybe I can put a name RGB. So now it's, and I can put compression, something like this. So now I created this RGB, and this RGB, it's actually, so it's not the values, but it's a colored map. So it's, if I look at it in my file folder here, then you will see it's, I can actually open it also in Windows, and you see exactly the colors, right? So it's not just a raw data, but it's a rendered view, okay? And now when I have that rendered view, I can go here to this folder, actually it's the same folder, and I can copy this code I have. So let's see. And now remember, I will put maybe some subfolder for testing. Like this. So now it's empty. And if I go to my R session, I'm now under Windows. I haven't tested it actually. I'm under Windows. So let's see if this is going to work. So I say some title. It can be insert title test. 1 to 6 geodetic, and I say test if test RGB. Let's take a look. So there's the file called test RGB, yes, and I put it in the local folder, which is test. I don't remember this K. What is the K for? I don't remember. I'll delete it when you don't remember what you did. So let's see if this works. No, I get a 127 error message. So let me see. I can delete a bit further this thing. Maybe this GDAL to tiles. Let me see. Maybe I don't have it. View terminal. I have to see if I have this GDAL to tiles. No module name OSGeo. Yeah, I will have to update the GDAL to tiles. But if I would run that in the, let me run it under Ubuntu. Should be much easier. I just have to copy that TIFF I created. So here's this little TIFF. And I copy it to this Exchange folder. And we'll try to do it. And so if everything is good, then it makes KML with all the pyramids automatically. It's very nice that people share that code. It's universal. And then you can create a large TIFF ground overlays that you can open in Google Earth. And again, if you put all the PNGs, if you put on a server, then you just send a KML file. So that's the last thing I wanted to show. I will still show that example just to wrap up. So the KML, there's many things you don't even know what you can do, but there's really a lot of things you can do with KML. You can make 4D GIS. You can also make voxels. It's possible. You can put photographs, embed the photographs, and you can also put the photographs in a display. So that looks something like this. So something like this thing. And this is really actually mind-blowing. Let me open this. It's also here. I just have to remember which one is the SM. Yes. So here's a photograph. Yeah, here's a photograph somewhere. Did I put some date? Maybe. Maybe I moved the photograph, but you can see the photograph like rendered like this. So it's like rendered in an object. So you can put a polygon and then you put photographs to represent something. So so that's also possible. Let me see the. I'm looking back at the Ubuntu version. Don't have to worry about my RAM. I see that my computers are slowing down a bit. So good moment to check the RAM. This was this folder data, and I had this exchange. There's the exchange, and here I put this RGB file somewhere. Where are you? Modified. Yeah, this one. So I will copy it to some local folder here. And now I can go to the RStudio. And I have to create here some test folder, test. New folder, call it test. And now let's try to do this command. I'll have to turn some things off. And so the code was this thing. Let's see, now I run it under Ubuntu. Let's put a new code. If I'm in the right folder, no. Let's remove all this. Clear workspace. And so we have to go to this folder. We'll go to this folder and let's try to run now the GDAL to tiles. Now it is running. And so it created this overlays, and you see we have in the test folder, we can look at it through open layers, Google Maps, so you can look at the different ways. We can maybe, let's try the Google Maps. This one doesn't show anything. Let's check the KML. Maybe this one I didn't put that it's because I don't see any KML created. Let me check. GDAL to tiles. It tries to find a domain GDAL tiles by. So how to create? I think it's the -k. That's the KML. -k force KML. Okay. So I just had to put here -k. That's the one I deleted. Let's do it one more time. Now I have the KML, and let's see if this works. Yes. And now we see it. We get this test, but zooms it somewhere. I don't know. It doesn't show it. Maybe it puts the whole world. No, it doesn't show it. But it generates basically the pyramids. Where is the area? Somewhere in Italy. I don't see it anywhere. Let me see. Do you remember that tile? Where is it? On the border with Switzerland or something? Yeah, I don't see anything. It's difficult to see, but I have to also turn off all these roads and stuff, 3D buildings. So it looks like something went wrong. Maybe I have to do with I forgot now. I haven't done this for some time. Maybe I have to reproject to the Latlon, but I have to project to Latlon, I think. Right? Probably I have to reproject. So I didn't do that. I took the European coordinate system. Yeah, the K supplied map uses 4326. So I will have to reproject first, then make that geotiff, and then I build the tiles. But it works. You get a KML, and you can open it, and it's also out of box. So I just couldn't make it now because this one, the geotiff, I will have to first reproject. So, and with this thing, I will stop now sharing live. Let me see if there's any questions. There's thing in the chat. So they were complaining about sound.
No, sounds okay.
Sounds okay. Okay. Uploading to Google Earth Web seems described here. So somebody shared that. Let me also put that in the Mattermost. So thank you, Floris. No, we don't want to watch commercial, but looks like it's explained here. So let me put that somebody shared. And this is how to also upload ground overlays. How to upload KML files to web, Google Earth. So yeah, let's take a look. Look at it, please. Let's see if it works. If you can get the ground overlays, that's how we'll be interested. And if you can also do the screen sharing. Let me stop the screen sharing, and I will stop now the live. Hmm.